Today we are learning about Lewis structures. Lewis structures are for covalent compounds, which means that they are nonmetals with nonmetals and that they are going to share their electrons. The first thing we need to be able to do is to draw electron dots. Electron dots are based on the number of valence electrons. So if we look at carbon on the periodic table, it's part of group 4, so you have 4 valence electrons, and we put 1 electron on each face. If we look for the electron dot for hydrogen, we see that hydrogen is in group 1. That means it has 1 valence electron, and we draw 1 dot. Both oxygen and sulfur are in group 6. It means they each have 6 valence electrons, and we have to have 6 dots. We go 1, 2, 3, 4, then we come back to the top for 5, and down the side for 6. Nitrogen is in group 5. It has 5 valence electrons. We need 5 dots. 1, 2, 3, 4, 5. And chlorine is in group 7. It has 7 valence electrons, so we have 7 dots. This picture is important because it tells us how many bonding sites one has. Carbon is the best one for bonding because we see that we have 4 unpaired electrons, which means we have 4 bonding sites or 4 places to put new atoms. Hydrogen only has 1 electron, which means it has 1 bonding site. Hydrogen can only have a maximum of 2 electrons because it's in the first energy level. Oxygen has an unpaired electron here and an unpaired electron there, so it has 2 bonding sites. Sulfur has 1 unpaired, 1 unpaired, for a total of 2. Here, nitrogen has 1 unpaired, unpaired, unpaired for 3 bonding sites, and here chlorine has 1 unpaired electron for 1 bonding site. The more bonding sites that you have available, the better sharer you are. The fewer number of bonding sites, the not so great sharer that you are. Hydrogen is not a great one, again, because it can only have a maximum of 2 electrons. Chlorine, however, being a halogen, they all want to attract 1 electron. They really don't want to share, they really would like to take an electron. Now, all of these examples are of nonmetals. You will notice that there are no metals present because we cannot use metals when we draw Lewis structures. So there are a couple of things that I had to keep in mind. If carbon is present in the formula, carbon will be the center because carbon has 4 bonding sites. But if carbon is not present, I look at my formula and I ask myself, which element has only 1 atom? Well, hydrogen has 2, oxygen has 1, so that means oxygen is going to be my central atom. Valence electrons for oxygen, I'm in group 6, so I put in my 6 dots. I see that I have 2 bonding sites, perfect location. I can come in here and put in my 2 hydrogens. Now each hydrogen is in group 1, so each hydrogen is going to bring 1 electron. This here is going to form a single bond, and this is going to form a single bond. So my final picture is going to be replaced, that pair of electrons with a dash, replaced with a dash. And those 2 dashes represent a single bond. So I could say here that I have 2 single bonds in water. Now I have 2 on hydrogen, 2 on hydrogen, but I need to check oxygen. I have 2, 4, 5, 6, 7, 8, 8 on oxygen. Let's look at NH3. N is going to be my central atom because I have 1 nitrogen and 3 hydrogens. Nitrogen, we said, is in group 5, so it has 5 valence electrons. I see that I have 3 bonding sites, so I can bring in a hydrogen and place in my unpaired electron places. Each hydrogen is in group 1, each one will bring in an electron. And we can see then that we have 2 electrons shared, 2 electrons shared, and 2 electrons shared. That's going to make 3 single bonds. I want to check nitrogen. 2, 4, 6, 8. Nitrogen obeys the octet rule. So I'm going to redraw my picture showing the 3 single bonds. Now in this particular case, we do have carbon present. So carbon automatically is the central atom with 4 bonding sites. This tells me that I have 4 chlorines. So I'm going to bring in my 4 chlorines. Now the difference here is that chlorine has 7 valence electrons. So each one of these guys has to bring in its own 7 electrons. So if I take care of this chlorine up here, I put my first one here because then I create that single bond. So here's 1, and then I do 2, 3, 4, 5, 6, and 7. Do the same thing here. I do 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. I can clearly see that all my chlorines have 8 electrons around them. And if I look at my carbon, I have 2, 4, 6, 8. So carbon also obeys the octet rule. So I can replace those pairs that are being shared with dashes. But it's very important that I go back in my final picture and I put those pairs of electrons around the outside of chlorine. Now, not every element or every compound is going to be neutral. So we learned a little bit about our polys yesterday. The first poly I have is ammonium. So ammonium we look up is NH4, 1 positive. There's only 1 nitrogen in this formula, so nitrogen is center. So we're going to put our 5 electrons around nitrogen. I see that I have 3 bonding sites, so I go 1, 2, and 3, but oh no, I have to have a 4th hydrogen, and it has to go on top. This hydrogen is going to bring in 1 electron to make a single bond. This hydrogen will bring in its electron to make a single bond. And this hydrogen will bring in its electron to make a single bond. But if I put one up here, I have a problem because now I have 3 electrons on hydrogen and hydrogen can only have 2. So what does the 1 positive mean? It means that you get to lose 1 electron. So one of these electrons gets to go away. It's actually going to be transferred to something else that wants that 1 electron. But what we have to do for our final picture then is we replace all of those with dashes. But we have to tell our reader that we did something different. We have to use brackets, and then on the outside of it, in the upper right corner, we have to tell the reader that we lost 1. Same thing if I gave you something like sulfate. Sulfate is SO4, 2 negative. S is going to be your center. You're going to put 6 dots around it. Shows 2 bonding sites, but I have 4 oxygens. 1, 2, 3, and 4. Now the problem with oxygen, it is in group 6, so it has 6 valence electrons, but it is the 2nd highest electronegative element, which means it's not a good sharer, especially when it's on the outside. So because oxygen and sulfur are in the same family, this rule that I'm going to give you applies to both. They like to play a game called play keep away. You're right, they don't want to share. So oxygen's 6 electrons are going to say to the sulfur, I'm going to keep my 6 electrons to myself and I'm not going to share. The sulfur says that's okay because I'm already sharing 2 with you anyway, and now my oxygen has 8. And this oxygen is going to say, well, I'm going to play keep away with my 6 electrons, and sulfur says, well, that's fine, I'm already sharing 2. But this oxygen down here says, I'm going to play keep away, and sulfur says, well, I can only give you 1. So I only have 7 around this oxygen. And this oxygen is going to say, I'm going to play keep away. And again, sulfur says, I only have 1 to give you, so I only have 7 here. Both oxygens need 8. So what does the 2 negative mean? It means that you get to gain 2. And you can bring in an electron and put it there, and you can put it there, and now you've created a single bond between these 2 and these 2. So my picture, when I clean it up, it's going to have 4 single bonds I've got to put those 6 electrons around the outside. And then I have to put it all in brackets and tell the reader that I gained 2. And you're like, hey, where did those 2 come from? Well, it came from a metal. So even though that this is a covalent compound made up of 2 different nonmetals, it has some ionic characteristics. And we'll talk about that more in a little bit.